Hi, welcome back to Circuits with Angel. Today, we'll be learning about capacitors and all the cool things we can build with them. And here is an example of a flip-flop. But before we get carried away, we must first learn about the components that make up this circuit. For example, the transistors are the brain of the circuit, controlling the LEDs, and the resistors are like the veins of the circuit that restrict current. But for all of this to happen, we must have the capacitor, the beating heart of the circuit that allows all of these to function. Now let's see how this component works. Capacitors work like a rechargeable battery. They charge up when voltage is connected, and when they are fully filled up with voltage, they discharge or release the voltage really quick. You can slow the charge of a capacitor with a resistor. You can also slow the discharge of a capacitor with a large resistor like a 100k ohm resistor, if you really want to slow the discharge. Discharge in capacitors can be dangerous in their larger sizes. We will not be dealing with capacitors above 48 volts. When using capacitors, you want to make sure that you discharge them after you use them in an experiment, because they can retain charge and discharge on you. So, one more time, I will remind you to discharge your capacitors if they still have any charge left. You should take a 1 mega ohm resistor and connect the capacitor's two legs with the resistor. This is probably the only time shorting components should be done. On the inside of the capacitor, you have two thin metal strips, separated by a dielectric material, like a thin sheet of paper. The sheet of paper stops electrons from just jumping over to each other metal plate. I took apart a capacitor to prove that there was indeed a sheet of paper, and after taking apart a few of them, I realized that the bigger the piece of metal plates are, the more capacitance a capacitor has. Before the end, I would like to talk about ceramic capacitors instead of electrolytic, because there's a big difference between the two. For example, the ceramic capacitor has no polarity and generally comes in really small capacitances. They also have a different symbol than the electrolytic capacitors, so don't get the two mixed up. Okay, that's all. Let's look at our points. 1. Capacitors are the beating heart of our electronic circuits. 2. Make sure to discharge your capacitors. Never apply voltage higher than the capacitor's voltage specification on the side of the capacitor.